Hello? As expected, the first part caused a lot of confusion. And unsurprisingly, a 200-kilometer comet is from the realm of fantasy, you know? But is everything really so fantastic? What exactly is hard to believe? That such objects exist? Yes, they are in abundance. That such an object could collide with Earth? Yes, quite possible. It's hard to believe only one thing, that such a catastrophe could have happened quite recently and somehow managed to go unnoticed. But is it? All the alternativists themselves claim that something fell on us in the 17th century, don't they? So why then does a simple calculation of their theories cause rejection, even though official science is not distinguished by sharpness in this matter? Have you ever heard what officials say about the origin of clay? Historians and biologists are somehow convinced that clay is horse manure and other organic matter that is decomposed. But do you know the composition of clay? I'll believe the official version if they show me a horse excreting aluminum oxide and silicon dioxide. But let's take things one at a time. So, could the planet have survived a collision with such a monster? Could people have survived? And could any traces of civilization remain? We know that the asteroid Apophis, with a diameter of only about 20 meters, would kill us all. That's what they tell us on TV. We've seen so many times in movies about the end of the world, how the planet is torn apart, how it's covered in lava, and the core is ejected. We've also seen Americans on the moon, the International Space Station in orbit, Iron Man, Batman, Spider-Man, and the Terminator. We've even seen John Connor. But these are all illusions, fantasies. It's just a curious feature of human psychology that allows us to shout that we're all being lied to, that no one is flying into space. And then to assert here that, according to scientists, a meteorite 10 kilometers in size is enough to destroy life. What if you're also being lied to about this? So, what's the real deal? We'll find out now. First, let's study the real consequences of meteorites colliding with Earth. On the website of the Imperial College London, by the way, there is a program that already has the basic formulas laid out, which can be used to calculate the effect of the Earth colliding with various celestial bodies. I suspect that all those who cry about the impossibility of survival have used a similar program in these same formulas. In that case, God Himself commanded us to use it. Here you can manually set some parameters, for example, the distance of the observer from the impact, the diameter of the body, its density, the speed of impact, the angle of impact, and also the density of the surface at the point of collision. Well, for example, it's water or rock or ice. Let's start by seeing what happens if an object 79 kilometers in diameter crashes into Earth. We calculated this diameter in the last part. Let's assign its characteristics according to the classical representation of meteorites. That is, it will be iron for us. We will set the standard comet speed of 51 kilometers per second and the impact angle of 45 degrees. And let it hit the rock. For example, in the Himalayas, and we are at this moment sitting, for example, in Moscow at a distance of 3,750 kilometers. The results are impressive. The crater is 1,590 kilometers. The fireball, visible from 1,700 kilometers away, will wipe out half of the Earth and instantly kill all living things on the third of the Earth. But note, the Earth's axis will not shift even a degree, and humanity will still survive, although it's not a fact that it will be for long. Months, 1.5 to 2. Now the same thing, but with a comet, that is, the comet body is much less dense. The result is a much smaller crater, although it is still 725 kilometers in diameter. And although it shakes much less, the consequences are still very heavy. But the Earth's axis did not shift again. Now let's imagine a 200-kilometer body strike. The results are quite sad. A crater 3.5 kilometers deep with a diameter of 1,380 kilometers. All structures on Earth are destroyed. Volcanic activity has begun. An earthquake of magnitude 13.3 on the Richter scale. To say nothing of, this bolt almost split the planet like a watermelon. Even the orbit shifted, but not the axis, not even by 0.5 degrees. Maybe I set the angle of descent or speed incorrectly? No, any angles don't significantly affect the situation, just like any speeds. In the end, we fill in the parameters of the calculation of the radius of the collision of the Earth with exactly the same planet with the same Earth. By itself, everyone died, but the axis almost didn't move. That is, it turns out that no forces, and even more so a comet or asteroid, cannot shift the Earth's axis. Maybe the scientists are wrong and have included some incomprehensible miracle formulas in the program. Remember this result well. In the future, we will definitely return to it, and it will allow us to make a shocking discovery. And now let's try to answer another question. Why couldn't we notice such a baba? The thing is, meteors mainly made of iron fall on Earth, and their bang is substantial, and the appearance is impressive. As for comets, they don't fall at all, although they scare us with this. And we are missing a very important detail. We have a megaton of sand and clay in front of our eyes, and we discuss it as if a metal meteorite fell. Meanwhile, iron is far from the most common element in our solar system, let alone in the galaxy. Iron and other elements heavier than iron only appear at the moment of a supernova explosion. It actually acts as a kind of star detonator. As soon as iron begins to synthesize in the core of a star, it means that the star will explode very soon. And the most common elements in space are, of course, hydrogen and helium. Carbon is in third place, followed by nitrogen, oxygen, neon, sodium, magnesium, aluminum, and silicon. Iron, however, is only in 16th place on this list. What are our deserts and clay pits made of? Deserts are made of silica in various combinations, including with aluminum. Clays are also made of silicon dioxide, aluminum oxide, and water, as well as carbon in various combinations. That is, from elements that occupy the 1st, 3rd, 5th, 9th, and 10th places, in terms of prevalence in the solar system and in the universe in general. And if we look at metals, then aluminum is the most common metal in the universe. It's logical to assume that our target asteroid terrorist will be made up of such a set. Of course, there will be iron there, but in minuscule amounts. Then let's look at our solar system and search. Are there any objects fitting the description somewhere else? Turns out there are. And we have many such objects in our solar system. They even have their own class, these so-called Centaur asteroids. There are more than 44,000 of them in our solar system. They have a very wide range of sizes, from 1 to 400 kilometers in diameter, and some are even larger. The vast majority of them are far from us, in the asteroid belt between Jupiter and Saturn, around Uranus, in the Kuiper belt, and in the Oort cloud. Many of them are moons of Jupiter, Saturn, Uranus. Let's take a look at some of them, those that fit most closely into our model. Here, for example, is one such moon of Saturn, Phoebe, and here's another one, Heron, wandering between Saturn and Uranus like a drunk. And here's Nix, it's lurking around Pluto. Yes, even Phobos and Deimos, the moons of Mars, are essentially the same category of asteroids, centaurs. And there are a lot of them. Take a look sometime when you're bored. So what do we know about them, besides their orbits and mass? We know that some of them contain unusual compounds like tholins, amorphous carbon, soot, olivine, and water vapor in small amounts. But that's in small amounts. What about in large quantities? We also know their density, well, not all of them, of course, but some, for example, the density of Chiron is about 2 grams per cubic centimeter, and the density of Phoebe is a whole 0.6 of a gram per cubic centimeter. It would seem, well, what's so special about that? Well, first of all, this means that they are not made of gas and not even water. Its density is 1, that is, it's not comets and not made of iron either. Its density is 8 grams per cubic centimeter. The difference is huge. However, any man who has ever built something with his own hands will immediately understand that Heron is made of something similar to a mixture, for example, clay. Its density is just in the range from 180 to 2 grams per cubic centimeter. And Phoebe is practically pure sand with a density of 1.6. In general, congratulations, you have just completed the Young Astronomer course. Forward open up new sandy clay asteroids. Well, we found what we were looking for. Such bodies exist in the solar system. Yes, not just exist, but there are many of them. And if so, then the probability of Earth colliding with such an object always exists. It cannot be dismissed under any circumstances. This is the main idea of this video. But we still haven't answered the main and crucial question. If this really happened to us, then why did we relatively easily survive the fall of such a giant? Why didn't the Earth explode to hell? Even if we plug into the mathematical formula of collision an object with the density of water, which is less than the density of stone or clay, the explosion is still significant. We will try to figure this out in the following videos. And if you see a flaw in my logic, don't hesitate to leave a detailed, articulate, and unambiguous comment under the video.